Hello there, Mr. Sutton back one more time in this chapter on quadrilaterals. This is the last one we'll be looking at, kites. We'll be using these properties to figure out all the sides and angles in kites. And as a little real-life bonus, we'll figure out some angles in a real-life kite. We're going to go through some properties of kites now. First property, a kite has two pairs of consecutive congruent sides. So it has two pairs of sides that are right next to each other that are congruent to each other, like this side over here and these two sides over here. This is a little bit different than a parallelogram where it's the opposite sides that are congruent. Here, the congruent sides are right next to each other. Second property, in a kite, the diagonals are perpendicular. Now, some of these kite properties read a little bit funny because they talk about a longer diagonal and a shorter diagonal. This one, for example, says opposite angles on the shorter diagonal are congruent. So here's what we're talking about. With a kite, you have a short direction and you have a long direction. We're just saying the short direction angles, this one and this one, are going to be the same. The diagonals also have their own relationship with each other. We already said the diagonals were perpendicular. It's a little bit more, though. The longer diagonal actually bisects the shorter diagonal in a kite. So here's our two diagonals. Again, we said they were perpendicular. So this longer diagonal is cutting the shorter diagonal into two equal halves. It doesn't work the other way, though. Notice that the shorter diagonal does not necessarily bisect the long one. In addition to bisecting the shorter diagonal, the long diagonal continues its bisecting with the angles that are across from each other going the long direction. So here's our long diagonal, and it's going to bisect these angles over here, and also we get two congruent angles from the bisection on the other side. So we're going to find some angles and sides in kites now using those properties we just learned. Pause the video and see if you can puzzle out the value of x in this diagram. So the property that would help us here is that our opposite angles on the shorter diagonal are congruent in a kite. So we can say that 2x and 111 equal each other. Dividing by 2, we get 55.5 degrees. Let's do another one. Pause the video and see if you can figure out the measure of angle J up here. All right, now it's tempting to just write 120 because they're opposite angles. But remember, the opposite angles on the long diagonal aren't always the same in a kite. It's the short diagonal opposite angles that are congruent. We can at least start, though, by saying that the measure of angle K is 88. And then, in a quadrilateral, if you have three angles, you just have to add those together and subtract it from 360 to find the other one. So adding this up with our other two angles, this is going to be, 176 plus 120. That's going to be 296. Subtracting that from 360, we get measure of angle J is 64 degrees. On this next example, we're trying to find the side lengths of this kite, and they're telling us it's a kite. That's important, otherwise we wouldn't know. So pause the video and see if you can puzzle this out. The key to doing this one is realizing that since you have a kite, you've got a perpendicular situation going on here. That gives us 4 right triangles. Since we have both legs in each right triangle, we can just use the Pythagorean theorem to find the hypotenuse. And the hypotenuse, it just happens, is the sides of this kite. So SV and ST, since we do have a kite, we know that these sides that are right next to each other are going to be congruent. Those equal just the square root of 9 squared plus 8 squared. So that's going to be 64 plus 81, so square root of 145. And we can't really simplify that anymore. There's no perfect squares. So we keep going. VU and TU are going to equal each other. That's going to be the square root of 7 squared plus 9 squared. So that's going to be 49 plus 81. That's going to be 130. And that doesn't have any perfect squares in it, so we leave that the way it is as well. Here's the final problem. See if you can figure out the measure of angle D in this real-life kite below. All right, this one's a little bit trickier. We do know that the opposite angles on the short diagonal here are going to be congruent to each other. We don't know what either of them are, though. We do know, however, that they're both exactly the same. So if we have two things that are the same, we can call them both x. And then we could say 2x, because there's two of them, plus your other two angles has to add up to 360. So that's 2x plus 204 equals 360. Subtracting, we get 2x equals 156. And then half of 156, that is going to be 78 degrees. So that's it for kites and quadrilaterals. What a beautiful way to end this, wouldn't you agree? Until next time, this is Mr. Sutton signing off.